Okay, check. Okay, here we go. So let's start with this. We're looking at the hypotheses. We're going to start from 1, and then we're going to go from 1 to 9. So hopefully that'll be fine. Question 1. Appropriate set of hypotheses. Now there's a couple ways of doing this. Depending on how you want to look at it, you could let mu1 be the male swimmers or let mu1 be the female swimmers. I'm just going to have the data presented as it is on the paper. And I'm going to say that mu1 is going to be the male swimmers. Now, there's nothing wrong with saying that mu1 is the average time of female swimmers. And you could certainly do the problem correctly that way. You just need to make the choice and be consistent with your choice. A set of hypotheses then would be, and this is kind of a dangerous one to do, because we don't know which one should be bigger and which one should be smaller, or you need to figure that out. So null hypothesis should be pretty obvious. That should almost always be 0. But the alternative hypothesis here is, well, which time should be smaller, the male time or the female time? So if males are faster, they should have a shorter, smaller time, meaning that mu1 minus mu2 should be less than 0. Why did that turn into a u? Mu2 should be less than 0. That's my appropriate set of hypotheses for question 1. Question 2. Question 2 is now going to ask me for a test statistic, a p-value, and a decision. So let's figure out our test statistic. But before we can do that, we should figure out, well, here's that 1, 2, and 3 part, right? Number 1, what is the center of my sampling distribution? And you usually get that from your null hypothesis. Null hypothesis tells us that that's 0. 2, the standard deviation, sigma, of x bar 1, x bar 2. Well, you can approximate that. We don't actually know what that is, but we're going to have to approximate that with the square root of S1 squared, which is 2.86, divided by the sample size of 5, plus S2, which is 4.83, divided by their sample size, which is also 5. It gives us this ungainly number. No problem. Just clean this up for you just a little bit. And let's just use 2.51. So that's the standard deviation of my sampling distribution. We should also make sure that there needs to be more than, let's see, sample size of 5. 5 times 20, which is 100 male swimmers. And more than 5 times 20, 100 female swimmers. Anytime you deal with mus. No, if you deal with the proportion, you don't have to. And 3, we have small sample sizes. we have small samples. So we should check the samples for normality. Since we cannot do this, we need to assume so if we were able to, we would be checking sampling distributions. But since we cannot, we're going to just have to say assume that the sampling distributions are normal. So that leads us to our test statistic. Our test statistic is going to be, well, that's going to be T. Smallest sample is 4, so T4. And that's going to be equal to, let's see, male time is 53.2 minus a female time of 64.6. Technically, we should be subtracting 0 since that's our alternative null, since that's our null hypothesis. We have to divide that by our sigma, x bar 1, x bar 2, which is 2.51. It gives us negative 4.542. That's our test statistic. P-value, that's going to be equal to the probability that T4 is less than negative 4.54. And do we have a number for that? Getting 0052. So that's a very small p-value, so the correct decision would be reject the null hypothesis. That's my decision. It doesn't ask you to interpret, so you don't have to interpret. If we were going to interpret, so not asked, but we have the, let's see, the data supports that the male swimmers have a lower average time than the female swimmers. Yeah, that's not asked for, but I feel wrong if I didn't actually put that in there. That takes care of questions 1 and 2. Are there any questions on those? Looking good? Let's take a look at 3. You're constructing a 90% confidence interval for a difference of proportions. You find x1 is 12, n1 is 25. x2 is 15 out of 38. We want standard error, margin of error, and a confidence interval. Okay, so the first thing which might give you problems is, what is p hat 1? Well, p hat 1 is just going to be 12 out of 25. What is p hat 2? Yeah, which would be 15 out of 38. Okay, so we're going to need those two if I want to find standard error. Since we are looking at a confidence interval, we're not making any assumptions that p hat 1 and p hat 2 are equal, or p1 and p2 are equal to each other. So the standard error is just the square root of, let's see, 0.48 times 0.52 out of 25 plus 0.3947 times 0.6053 divided by 38. That's my standard error. Margin of error, we want a 90% confidence interval. So for that, we're going to need Z star. And Z star 90% is 2 point, I actually don't know what it is. What is it? Or is that 1.96?
Wait, 90% is 1.645.
1.645?
Yeah.
Thank you, that sounds about right. So this is from inverse normal?
Yeah.
Or what is that, inverse or program, right?
Yeah.
And so the margin of error is just going to be equal to that Z star 1.645 times 0.1276, my margin of error. So confidence interval then, P1 minus P2 is going to be equal to, what is that, 0.48 minus 0.3947 plus or minus 0.2099. 48, that's 38. I can't subtract this in my head.
It's 0.0853 is the mean. Do you want the confidence interval?
Oh, 0.48 minus 0.3948.
0.0853.
53?
Yeah.
So that's 0.0853 plus or minus that. Or in other words, P1 minus P2 needs to be all right, so hit me. Negative 1237.
And 0.2943.
There we go. Questions on 3, yeah.
Why do they call them P hat?
P hat because it came from sample data.
So. Okay,
Anytime it comes from sample data, it's P hat.
but how do we?
That was in
are we
English.
just assuming that it's the same thing? 'Cause they're-
It's kind of implied that once we're taking 12 out of 25, that's a sample from something.
Okay.
Let's take a look at question 4 then. If we have an SRS size 200 from a population having 0.7 success, an independent sample size 300 is taken and has a proportion of 300. What am I even saying? An independent SRS of size 300 is taken from a population having a proportion of 0.5 successes. The sampling distribution of the difference of sample proportions has what mean? Okay, so what we're actually asking is, what is the mean of P1 minus P2? Well, that's just going to be P hat 1 minus P hat 2. This P hat 1 minus P hat 2 . 0.2. Feels like a trap, doesn't it? Oh, wow. Those are.
Yeah.
Feels like a trap, right?
Yeah.
Feels like a trap.
When we see the next one, and we're like, okay.
This is a continuation. Thank you for being so frank and forthright. The sampling distribution for a difference of sample proportions has what mean? Okay, so are we talking about a confidence interval here, or are we talking about a test? Well, they're not asking us to test anything, are they? Okay. Yeah, right. But remember, we're dealing with proportions. So if you do a test, you have to compute PC.
Yeah.
But if you're not doing a test, then you don't have to compute PC. So they're not asking us to test anything. So we should use the standard error for a confidence interval. Okay, so that's going to be equal to sigma P1 minus P2. Wait. That's going to be the square root of that is 0.7 times 0.3 divided by a sample size of 200 plus 0.5 times 0.5 divided by a sample size of 300. .434. Is that what I gave you, Oz? Yeah. So this is just my remember. Test uses PC. sampling distribution does not use PC. Any questions on 6? 7? Actually, let me check to make sure we're still recording. Are we still recording? That looks pretty good. 6. A 90% confidence interval for the difference of means is to be conducted. N1 is 15, N2 is 29. Drives Josh crazy that you have 2 samples of different sizes. It's hilarious, but understandable. X1 is 12, X2 is 16, S1 is 8.5, S2 is 4. Assume all conditions for the confidence interval are met. Let's calculate standard error, margin of error, and a confidence interval for the difference of means. Okay, so let's.
Oh, sorry. If the problem already says that like all the conditions have been met, should we still write out 1, 2, 3?
No, you don't need to, but I think it gives you a nice framework. The only thing that you can really skip is 3. Okay, 1 is really nice because it tells you the center of that sampling distribution. So 1, the center of the sampling distribution. Oh wait, I'm sorry, this is x bar 1 minus x bar 2. That's going to be equal to 12 minus 16, right? It's negative 4. 2. We have sigma. Equal to the square root of, was that 8.5? Divided by 15. The next one is 4. Over 29. Clean that up. Wait, what did I do?
So we're just saying 4 times 2.
That's better, right? Again, no need to test.
The answer is different though.
Yeah.
That's weird. Just give me a second. Do not need to test 5% rule since conditions have been met. Okay, so where did we go wrong here? Yeah. 8.5 and 4, right? 8.5 out of 15. 4 out of 29. Oh, you know what? I need to do all of this over again. There we go. 2.32. I wish this did squares. That'd be really nice. Three. Do not need to check sampling distribution. Since conditions have been met.
You can state that on the test.
No, that's just for you reading the notes. Okay, and then now we can get to that standard error then, right? Okay, so standard error is equal to 2.32. This is for a mean, so we need a T star. And degree of freedom is 14. Did they give you 90%? So what is that? T star 14? 1.761. And that's from inverse T command or the inverse T program. Margin of error is going to be 2.32 times 1.761. Or 0.86. And finally, we have the interval itself. Mu1 minus mu2 is going to be equal to, let's see, 12 minus 16. 12 minus 16. Wow. Wow. Thank you. Who was that? Oh. Which is equal to -4. Or to put it the other way, mu1 minus mu2 should be between that negative 0.086 no oh negative I'm really dumb. Negative 8.0809 oh that's fine to 0.086. I think that's right. Looking good? We always pick it from the smallest sample. Okay, so we have our unemployed people more likely to commit a felony than employed people. 5,000 employed and 20,000 unemployed. Wow, where do they find 20,000 unemployed people, first of all? That's a lot of unemployed. Okay, never mind. Retracted. Which test or interval would be most appropriate to answer the question? Well, I think it should be a test, right? Should be a test. And do we want to test a proportion or do we want to test a mean? Like, do we want to test an average number of, like, say, the average number of crimes committed, or we just want to know what proportion of the people committed a crime? Probably just a proportion, right? So this should be a test for two proportions. Naturally, there's only one choice. So a z-test for two proportions. We can't do a t-test for proportions. It's always going to be a z-test. Eight. Boy, they really hit you with these standard error and test statistics on this review sheet, don't they? All right, let's do this. Sample 1 has an X bar of 12 and S1 of 4 and N of 32. Sample 2, let's get we're testing mu1 is greater than mu2 and value of it. So let's get our standard error. Standard error, that's going to be equal to sigma X bar 1 minus X bar 2. That's going to be approximately equal to the square root of, what is S1? 4. So 4 times 4 out of 32 plus 5 times 5 out of 29. It's equal to that number. Clean this up a little bit. My standard error. Test statistic is going to be, that's going to be a t with how many degrees of freedom here should we use? We're seeing N1 is 32 and N2 is 29. 28, yeah. T 28. So that's going to be R1, which is 12, minus X bar 2, which is 9.8, you said?
Yeah.
9.8. We're going to divide that by my standard error, 1.167. It's going to be 1.885. Now my p-value, we're going to take a look at for our p-value, we're seeing that our alternative hypothesis is a greater than alternative hypothesis. So we need to know the probability that T28 is greater than 1.885.
We use TCDF.
TCDF, yeah.
0.035.
0.35?
0.035.
Give me one more decimal.
0.0349.
And we should write that here, TCDF. Use TCDF. Okay, I think that's it for question 8, right? Number 9. So the first one is 13 out of 20, and the second one sample is 15 out of 19. So let's find the standard error for a confidence interval. confidence interval, you do not use PC. So standard error is going to be equal to the square root of, see, 13 out of 20 is 0.65. Thank you. 0.65 times 0.35 happened out of 20 plus 15 out of 19. Geez, 7895 times 0.2105 divided by 19. What's that? 1419. No, B, for a hypothesis test, now we compute PC. PC is going to be equal to the number of successes, which is 13 plus 15, divided by the total number, which is 20 plus 19. PC 7179. Now that I have PC, I can compute the standard error. That's going to be equal to the square root, the 0.7179 times 0.2829.
Oh, you put in the wrong number.
I did?
Yeah. 71, put 7171.
I got some.
Huh? 7179 or 71?
Yeah.
Can you just round it to? Can you do like 0.7?
Since we're dealing with proportions, I do try and keep it at 4.
Okay.
Plus, and that's going to be the same thing, 7179 times 0.2821 out of 19. Ooh, 1442. Subtly different. Not that different from each other, right?
No.
Yeah, you're probably going to find that that's true, that PC is usually not that far different.
It's a little higher.
A little bit higher, yeah, just a little bit bigger. Okay.
Yeah.
We didn't finish problem 1?
No, we did. Yeah, we did.
Okay.
Looks like we finished it.
Yeah. So,
Okay.
yeah,
There we go. Good luck.